This lecture goes over the Pythagorean theorem, or the Pythagorean formula, and the trigonometric functions of sine, cosine, and tangent, with which we'll use SOHCAHTOA. When we're using the Pythagorean formula, or sine, cosine, and tangent by means of SOHCAHTOA, note that we can only do that with right triangles. It's very important that you don't try to use the Pythagorean theorem on something that's not a right triangle, or sine, cosine, and tangent with something that's not a right triangle. A number of you did that on tests. So let's go ahead and go over the Pythagorean theorem. In a right triangle, the sum of the squares of the lengths of the legs, so the lengths of the legs are here, A, and down here, B. So the sum of the squares of these two is equal to the square of the length of the hypotenuse. And remember, the hypotenuse is always the side that's across from the right angle. Now, the way that we write the Pythagorean theorem is by using a squared plus b squared equals c squared, where a equals a side, b is a side, and c is the hypotenuse. So here are some examples of how we can use that. Here we have another triangle ABC. We see that our angle measure is at angle C, which means side C here is the hypotenuse. Not sure why that did not draw for me. Here we go, there's C. And since this is already labeled side A, and it's across from angle A, that means this is our side B. So as it says here, B equals 12 and C equals 13. So we plug those values in to find our missing side of A. So if A squared plus B squared equals C squared, A squared is what we're looking for, or A, so we just leave that alone. We substitute in 12 for our B value, and we substitute in 13 for our C value. Then we find the square of both of those. So 12 squared is 144, 13 squared is 169. Then in order to get a squared by itself, we subtract 144 from both sides. And what's left is a squared equals 25, and 25 has a nice simple square root of 5. So that means the measure of angle A was 5. And if you want, you can check that. So that would mean 25 squared, because that's a squared. 25 plus, this is a squared plus b squared equals c squared. So 25 plus b, which is 12, plus 144, should equal 13 squared. So let's go ahead and get our calculator for a moment. 25 plus 144 equals 169. We take the square root of that, and it does equal 13, which is our side C. So that means we found the correct answer. Let's look at one more example. This time, we're looking for the hypotenuse. So over here, the hypotenuse is C. So we don't have to do as much algebra to get to this answer. So again, we begin with our Pythagorean theorem, where a squared plus b squared equals c squared. A is 20, b is 30, so we plug those in. 20 squared plus 30 squared equals c squared. 20 squared is 400, 30 squared is 900, and we still have that equal to c squared. 400 plus 900 equals 1300, and then we take the square root of both sides to get c by itself. 1300 does not have an even square root, so we round it to the nearest tenth, and we get 36.1. So let's go ahead and do some more practice problems. So I'm on a new page here with my practice problems. And I'm going to look at my first problem. I want to solve for x, and I see that x is across from the right angle, which means x is my hypotenuse. So x squared is going to equal the sum of my other two sides squared. So that's going to be 12 squared plus 32 squared. Now I remember that 12 times 12 is 144. I don't off the top of my head remember what 32 squared is, so I'll use my calculator. 32 squared is 1024, so I'm going to go ahead and write that down. 1024. So x squared equals 1168. So let's find out what the square root of that is. 1168. So I'll go back to my calculator. I'll go ahead and add my 144. And the square root of that is 34.17. So I'm going to round to the nearest tenth. So I'm going to take that as 34.2. So I'll go ahead and write that down. X equals 34.2. Let's go ahead and take a look at our next problem. If I look at this problem, I see that across from my right angle is the number 13. So that means 13 is going to be my hypotenuse. So 13 squared is going to equal x squared plus 12 squared. I'm going to go ahead and algebra this up to get x squared by itself. So that means I'm going to subtract 13. No, I'm sorry. I'm going to stop that right now. My next one, I find my right angle. I look at what's across from my right angle. And that's the side that's 13. So that means 13 is going to be my hypotenuse. So my whole equation is going to be equal to 13 squared. And that is going to be equal to the sum of the squares of the other two sides. So that means x squared plus 12 squared. I'm going to go ahead and do some of my algebra right now to get x by itself. So the way I'm going to do that is by subtracting 12 squared from both sides. So I'm going to rewrite my equation, and I get x squared equals 13 squared minus 12 squared. So x squared equals 13 squared is 169. Fix that. There we go, is 169. And 12 squared is 144. So I'm going to go ahead and put that in my calculator. 169 minus 144 equals 25. So I get x squared equals 25. So that means x equals 5. Now I'm going to look at my next problem. I'm going to scroll down a little so I can see it better. This next problem is similar to one that you had on your test. And it's using an isosceles triangle, which means that the two sides here are the same length. When I drop down a height line or an altitude line and have it form a right angle with the base in an isosceles triangle, that means it splits the base into two even segments. So that means both of these pieces of the base are going to be 4 units long. So now I have a new triangle. When I just look at half of this, which is going to be 9 here, 4 here, and my right angle will be here. And this was x, which was my altitude. So my equation for this, 9 is my hypotenuse, so 9 squared equals x squared plus 4 squared. I'm going to do my algebra first. So I'm going to subtract 4x squared from each side. So I end up with x squared equals 9 squared minus 4 squared. So x squared equals 81 minus 16. 81 minus 16 equals 65. So x is going to equal the square root of 65. I put that into my calculator already. The square root of 65 equals 8.06. So I'm going to round that to 8.1. So x equals 8.1. Now over here we have a rectangle, and we're given two sides of the rectangle, and we know it's a rectangle because we have two right angles here. So I'm going to go ahead and look at what's across from the right angle, and that's x. So x is my hypotenuse. So x squared equals 31 squared plus 14 squared. I'll go ahead and use my calculator for that. 31 squared is 961. I'll go ahead and write that down. 961 plus 14 squared equals 196. So I'll go ahead and add those two together. It's 196 plus 961 equals 1,157. And I'm going to see if that has a nice square root to it. It doesn't, so we'll go ahead and we'll round to the nearest tenth. So my answer then is going to be x equals 34.0. Oops, that was kind of an ugly 0. Let's go ahead and erase that 0. 34.0. I'm going to go ahead and scroll down. Actually, I'm going to move down to, we have two story problems to do. Here's our first one. Clyde makes a triangle using 3 sticks of lengths 20 inches, 21 inches, and 28 inches. Is the triangle a right triangle? Explain. So what we need to find out is, can these numbers of 20, 21, and 28 be set up in a way so that they fulfill the equation a squared plus b squared equals c squared. Now whenever we're doing this, our hypotenuse is always our longest. So our biggest number is 28. So we're going to set 28 as c. So I'm going to see, does 28 squared equal 20 squared plus 21 squared? So I'm just going to say, is this true? I'm going to go ahead and do my math. So here's my calculator. I'm going to move it over here. 28 squared equals 784. I'll go ahead and write that down. 784. I'm still trying to find out if this is true. 20 squared is 400. I'm going to see what 21 squared is. So 21 squared is 441. So write that down, 441. So, does 400 plus 441 equal 784? No, it equals 841. So 784, we end up asking, is it equal to 841? No. So that means his triangle cannot be a right triangle. Our next question says that construction workers are building a marble sidewalk around a park that is shaped like a right triangle. Each marble slab adds 2 feet to the length of the sidewalk. The workers find that exactly 1,071 slabs and 1,840 slabs are required to make the sidewalks. So I'm going to go ahead and draw that. So my first one here is going to be 1,840 slabs. Each slab equals 2 feet. So I'm going to find out what that total length is. 1,840 times 2 is 3,680. So I'm going to put that in here. Equals 3,680 feet. Now my other side is 1,071 slabs. So I'm going to multiply that by 2. 1,071 times 2 equals 2,142 feet. I'll go ahead and write that down. 2,142 feet. Now the question it asks, how many slabs are required to make the sidewalk that runs along the side of the park? So what I'm going to do is I'm going to find out what is this. I'll call it c squared. Actually, it's going to be c. It's only when I put it in my equation. So I'm going to find the length of this, and then once I find the length, I'm going to divide it by 2 because each of my slabs is 2 feet in length. So c squared is going to equal 2,142 squared plus 3,680 squared. So we've got some pretty big numbers that we're dealing with. So let's find out what those equal. I still have my 2,142 in the calculator. I'm going to go ahead and square that. And it's gigantic. But I'll go ahead. I'm going to use edit, copy, and I'm going to see if I can just paste that number here so that I don't have to try and remember it. And then I'm going to go ahead and fill in the rest of my equation. C squared equals one gigantic number plus, I'm just going to open another calculator, and I get 3,680 squared. I'm going to go ahead and copy that one as well because I'm lazy and I don't want to memorize that number to write it down. So now I'm going to go ahead back to this number. Whoops. I'm going to recopy this number. Go to my second calculator. So this is my second number. So I'm going to go ahead and add to that my first number, which I had saved, which is very helpful. And I get another gigantic number. Copy. So I get that c squared is equal to, paste that number in here. So now I'm going to see what the square root of that number is. The square root of that number is just 4,258, which looks like it has a lot in common with these numbers. It looks like a reasonable number. So even though we ended up with some gigantic numbers, this number looks pretty good. So C equals 4,258. I'll go ahead and write that down. C equals 4,258 feet. And then I'm going to say divided by 2 feet per slab. So 4,258 divided by 2 equals 2,129. So I need 2,129 more slabs. I'm going to go ahead and pause there before we go ahead and move on to SOHCAHTOA using our trigonometric functions of sine, cosine, and tangent. Now we're moving on to our trigonometric ratios, which are sine, cosine, and tangent. So sine is abbreviated as sin. Cosine is abbreviated as cos. And tangent is abbreviated as tan. If you remember from class, we learned SOHCAHTOA to remind us that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So and over here, we see that we have those same formulas written out for us relating to angle A. Now the reason we've put our trigonometric ratios in the same lecture as the Pythagorean theorem is because these trigonometric ratios can only work in a right triangle. Later on, we're going to look at the law of sines and the law of cosines again, and those can work in any kind of triangle. But using sine, cosine, and tangent with SOHCAHTOA, where we're setting up ratios like this, can only work with right triangles. So here we have our examples. If we have triangle A, B, C, and we have our side lengths labeled, the sine of angle A is the opposite over the hypotenuse. Opposite of angle A is BC, which is 5, and hypotenuse of that triangle is BA, which is 13. So this ratio is the ratio for sine of angle A. Then we do the same thing. Cosine of angle A is going to be the adjacent leg over the hypotenuse. So we set it up as 12 over 13. So sine of angle A is going to end up equaling 0.92. And then finally tangent is equal to opposite over adjacent. So it's going to be 5 over 12, which we see here, 5 over 12. Now remember, when you're trying to figure out which is the opposite angle and which is the adjacent, which is the hypotenuse, opposite's the easiest one to find in that its name implies what it is. It's opposite the angle you're looking at. Sorry about that. The hypotenuse always has to be opposite the right angle. So when you're trying to determine what your adjacent side is, it's going to be the side next to your angle. That's what adjacent means. So it's next to your angle, but not the hypotenuse. So that's how we determine which is the hypotenuse and which is the adjacent. So let's go ahead and look at some examples. So here we're being asked to find sine, cosine, and tangent of angle R and sine, cosine, and tangent of angle S. So for my first example, I'm actually going to go ahead and put the numbers up here for myself. R is 16, S is 30, and T is 34. So first I'm going to start with angle R. So the sine of angle R is the opposite over the hypotenuse. So sine R equals 16 over 34. And it asks me to round the decimal to the nearest hundredth. So 16 divided by 34 equals 0.47. So I'll go ahead and write that down, which equals 0.47. My next one, cosine of angle R. Again, we're using SOHCAHTOA. So my cosine of angle R is the adjacent over the hypotenuse. So cosine equals 30 over 34. And let's see what we get for that. 30 divided by 34 gives us 0.88. So I'll go ahead and write that down. Equals 0.88. And then finally, tangent of R equals opposite over adjacent. So opposite is 16, adjacent is 30, so tangent of R equals 16 over 30, which equals, let's take a look, 16 over 30, which equals 0.53. We'll go ahead and write that down. 0.53. I'm actually going to go ahead and cross off this problem, because if we've got R and S, we're getting enough practice here. So now I'm going to erase that, because now we're looking at angle S. And I'm going to go ahead and write over here, just so I'm not in the mess on the other side of the screen. So sine of angle S equals opposite over hypotenuse. So it's going to equal 30 over 34, which we already know equals 0.88 because we can see it over with cosine. Cosine of S is going to equal my adjacent over my hypotenuse, so that's going to equal 16 over 34. And again, I've already done that math over here when I was looking at sine of R. So that's going to equal 0.47. And finally, tangent of S is going to equal adjacent, which is 16. Sorry, it's going to equal opposite, which is 30, over adjacent, which is 16. So 30 over 16. So it's always going to end up being the inverse of what one of the other angles in the triangle is, which is not super helpful information, but let me go ahead now and find out what 30 divided by 60 is. By 16 equals 1.88. Go ahead and write that here. So seldom are we actually needing to just write down the ratios. Usually we're using our sine, cosine, and tangent to find some kind of missing information in a triangle. So let's look at these next few triangles and see what information is missing and how we can use sine, cosine, and tangent to fill it in. So over here we're beginning with angle A. So x is opposite of angle A. And over here is a 7, and the 7 is going to be adjacent to angle A. I know it's the adjacent and not the hypotenuse because it's not opposite the right angle. So that means if I've got opposite and adjacent, again, we're using our SOHCAHTOA. Adjacent and opposite, tangent is what has adjacent and opposite. So that means tangent of 36 degrees should equal my opposite, which is x, over my adjacent, which is 7. And then I'll go ahead and multiply each side by 7 to get the x all by itself. So 7 times the tangent of 36 degrees equals x. So to find x, I'm going to go ahead and put that in my calculator. Just a reminder, things are put in my calculator in a slightly different order than they're put in your calculator. So I'm going to put in 36, find my tangent of it, and then I'm going to multiply that by 7. And that equals 5.1. which seems like a very reasonable size based on the way that my picture looks. So x equals 5.1. And our next triangle, we have angle W. We have a 12, which is opposite angle W, and then we have x, which is opposite the 90-degree angle, so x is our hypotenuse. So opposite and hypotenuse means we're dealing with sine. So sine of 63 degrees equals opposite, which is 12, over the hypotenuse, which is x. I want to get x by itself, so I'm going to multiply both sides by x first. I get x times the sine of 63 degrees equals 12. And then I'm going to divide both sides by sine of 63. So I get x equals 12 divided by sine 63. So let's go ahead and put that in our calculator. 12 divided by 63 sine equals 13.47. 13.47. And when I look at my diagram, I can see that 13.47 sounds about right if my other side is 12, and I know based on the Pythagorean theorem that my hypotenuse has to be longer than 12. So let's go ahead down to our next question. So finally we have angle M. We're looking for what's opposite of it, and again we have a hypotenuse. So again we're going to end up using sine. So sine of 15 equals, our opposite is x, our hypotenuse is 12. I'm going to multiply both sides by 12. 12 times sine of 15 equals x. I'll put that into my calculator. 15 sine times 12 equals 3.11. Which again, given how my triangle looks, 3.11, if this side is 12, that seems reasonable because this does look like it's about a quarter of the hypotenuse. So now let's move into some problems where we are solving for an angle. So here's an example for us. We want to find angle T. And based on this diagram, we have what's opposite of angle T, and we have the hypotenuse of angle T. So as you can see, we're using sine then, because opposite and hypotenuse is sine with SOHCAHTOA. So sine of t equals 29 over 34. And then to get the t by itself, we have to use inverse sine. We divide both sides by inverse sine, and then our new equation ends up being inverse sine of 29 over 34 equals the measure of angle t. When it has that little m there, that means measure of angle t. So, using a calculator, we'll just go ahead and confirm that that's correct on our example. I do 29 divided by 34, and then I take the inverse sine of that. Oh, I forgot that I have to get the answer before I can hit inverse sine in my calculator. I'm sorry about that. 29 divided by 34. Now I take the inverse sine, and I get 58.5 degrees, which is what we get in our example. And looking at the next things, unfortunately, a little bit of my directions somehow got covered up there. But what we're doing is we're trying to find angle B to the nearest tenth. So if I look at angle B, my 14 that I have here is the opposite side. My 8 is the adjacent side. So opposite and adjacent use tangent. So I'm going to set up my equation. Tangent of B equals 14 over 8. Then to get B all by itself, I have to multiply each side by inverse tangent. And then I get the measure of angle B equals the inverse tangent of 14 over 8. So let's go ahead and put that in our calculator. 14 divided by 8, inverse tangent, I get that angle B is 60.2 degrees. And again, since the examples we're looking at right now are drawn fairly close to scale, if we eyeball this, it does look like it's pretty close to 60 degrees. Let's go ahead and look at our next example. Again, we're looking for angle B. So here we have the hypotenuse and we have the adjacent. And if we think about SOHCAHTOA, cosine is adjacent over hypotenuse. So our cosine of B equals 25 over 30. We'll divide both sides by the inverse of cosine, and we end up with the measure of angle B equals the inverse cosine of 25 over 30. So let's go ahead and put that in our calculator. 25 divided by 30, inverse cosine, and I get 33.6 is the measure of angle B. Again, looking at my diagram, that seems like a pretty reasonable answer. Let's go ahead and finish up with our last example. One more time, we're looking for angle B, and I have the adjacent angle, the adjacent side, and I have the hypotenuse. So again, with adjacent and hypotenuse, I'm going to use cosine. So cosine of B equals 7 over 39. So the measure of angle B equals the inverse cosine of 7 over 39. Put it in our calculator. 7 divided by 39, inverse cosine, we get 79.7. For our measure of angle B. So that's how we're going to use sine, cosine, and tangent to find a missing side or a missing angle. So just doing a little bit of recapping then. Let's see if I've got any more room here. The Pythagorean theorem and sine, cosine, and tangent all need right triangles to work. And if we're using the Pythagorean theorem, we need a right triangle, and we need to know two sides with two sides. If we don't have two sides, or we don't have a right triangle, we can't use the Pythagorean theorem. There might be some rare instances where we have a triangle with two sides of the same length. So it would look like we don't have two sides if we only have one, but our general rule of thumb is we have to have a right triangle and we have to know two sides to find the third side with Pythagorean theorem. Sine, cosine, and tangent. Work off of our little mnemonic of SOHCAHTOA. And we can either have two sides to find an angle, or an angle plus a side to find a second side. So those are how we use our trigonometric functions and the Pythagorean theorem.